How much time before there's regular travel back and forth to Mars? Like a real civilization on Mars?
Well, I think it's going to take a while to build a real civilization. The threshold that really matters is we're getting past the Great Filter. Do we have enough resources on Mars such that if the spaceships from Earth stop coming,
You can survive.
yeah, you got to have all the things necessary to sustain civilization on Mars. And the reason that the ships from Earth stop coming could be World War III, or it could be due to a slow decline of civilization.
Hey everyone. Welcome to Tech River. Have you ever wondered if we could live on Mars someday? Well, the answer is a resounding yes. Please make sure to watch till the end for a bonus clip of Neil deGrasse Tyson's take on this idea. Elon Musk, among others, has been exploring the idea of terraforming the red planet to make it habitable for humans. So how exactly would that work? One idea that Elon Musk has proposed is to heat up the frozen carbon dioxide in Mars' poles to release gas, which would increase the planet's pressure and temperature. In fact, he's even suggested using continuous, low fallout nuclear explosions to simulate artificial suns, in order to make Mars more hospitable. The goal of terraforming Mars is to build up its atmosphere and create a stronger greenhouse effect, allowing for global warming and vegetation growth. This would require keeping the planet warm enough to allow liquid water to remain stable on the surface, and protecting the new atmosphere from being lost to outer space. But there's a catch. The first level of terraforming is at 60 millibars, which is still 10 times lower than Earth's atmospheric pressure. That's why we'd need to gradually increase the atmospheric pressure to the Armstrong limit of 60 millibars, where humans could move around Mars with just a breathing apparatus, and even grow plants in the soil. The first step in terraforming Mars would be to build up its atmosphere, and one way to do that would be to release the vast amounts of frozen carbon dioxide stored in the planet's poles. As this gas is released, it would raise the planet's temperature and pressure, making it more hospitable to life. But that's just the beginning. In order to make Mars truly habitable, we'd need to create a stronger greenhouse effect and global warming, which would keep the planet warm enough to support liquid water on its surface. This would allow for vegetation growth, which could help to further increase the amount of oxygen in the atmosphere. To protect the new atmosphere from being lost to outer space, we'd need to create a magnetic field around the planet. This would require the development of advanced technologies, but it's not impossible. In fact, researchers are already working on ways to create a magnetic shield that would help to protect Mars from the solar wind. Of course, all of this would take time and a lot of hard work. But the potential benefits of terraforming Mars are enormous. Not only would it give us a backup plan in case something catastrophic happens to Earth, but it could also provide a new frontier for exploration and discovery. So let's keep dreaming big and working towards a future where we could potentially nuke Mars to create a new home for humanity. And here is the bonus clip. Please don't forget to like and subscribe to stay ahead in the curve with videos like this.
The Joe Rogan Experience.
What did you think about Elon Musk's idea about nuking the poles of Mars in order to make it warmer?
Yeah, so some of these are kind of pie in the sky ideas,
Right.
but let's get to what he's trying to get at.
Yeah.
What you want to do is you want to introduce warmth, you want to block the ozone, you want to block the ultraviolet so that you can protect organic life. All right, so we have an ozone layer, it's the 3 oxygen atoms, O3, and ozone likes ultraviolet light. So ultraviolet light comes from the sun and gets eaten by ozone. Gets eaten. And when you do that, the ultraviolet light doesn't make it to Earth's surface. So even though they say, oh, wear sunscreen and sunblock 45, yes, that's for the 1% of the ultraviolet that gets through the atmosphere. If you're above the atmosphere, you are fried. So, because ultraviolet is highly hostile to organic molecules and what we're made of as life. So you want to protect, you want to give life a chance. So you want to not only heat Mars, you want to find a way to block the ultraviolet light coming from the sun. So you need some mechanism, if not ozone, or just live underground, for example. Okay? And so I don't think we should think of the idea as a literal thing, but just it's a general principle of what you want to accomplish on Mars in doing so. So you want to warm it, you want to protect what could be the future of biochemistry, and then you seed it. And then you wait. You don't want to wait too long, you want to sort of speed it up if you could. And then you terraform Mars. SpaceX has. I visited him a couple of times. He's got a mug you can buy there. Then it has Mars on it. Okay, and then you put hot liquid in it, and Mars turns to an arable blue-green marble.
That's hilarious.
So yeah, it's very good. And it doesn't tell you that when you say, "Oh, I got a Mars mug," you know, and you show it off, and oh my gosh, when did that happen? It's an Earth mug, but it doesn't look like Earth.
There's a lot of people that go on.
Also, we
camping.
think there's a lot of water that was once on Mars, which is a certainty, and we think it's just sitting below in a permafrost. So you wouldn't have to bring water to Mars. By the way, in the really distant future, you can just redirect a comet and get all the water you need. But
How far distant is that?
the comet's everywhere, dude. We're in a
Right.
shooting gallery.
Yeah, that's not what I asked.
Oh,
how
what-
far
oh.
away do you think it is before we could redirect?
How far
one?
away in time?
Yes.
Okay, sorry. We know how to do it, but there's no real incentive. So there's no funded engineering plan to do it, but we know how to do it on paper.
We know how to do it in a conceivable way.
Oh yeah. So first of all, it happens with or without us because we are in the shooting path of countless thousands of asteroids and comets.
Right.
So what you would do is you'd find one that's headed close to us anyway, in the 7th orbit down the line or the 100th orbit down the line, and then you'd slightly deflect it in such a way that it would then collide with Mars or even Earth if you wanted, if Earth needed some more fresh water.
Yeah, I heard that there's a possibility.
But the problem is if something really big that would fill lakes if that collided with Earth, that would just be bad for life on Earth. Because it's a spontaneous deposit of energy that can change the climate so you want to do that on a planet that you're trying to terraform.
Isn't that the speculation of how water got here in the first place?
So the jury's still out on that. There are tags in the oceans, in the water molecule, that tell you that the water must have come from more than one source. So that's what's confusing things. We want it to be a simple thing. It all came by comets, or it all came from inside the Earth through volcanoes. Volcanoes emit lakes, and historically, lakes and oceans worth of water just out of their calderas. So the problem is, as we say in science, overdetermined. There's plenty of comets to have delivered all the water. There's plenty of water that could have come out of volcanoes to give us all the water. So, but in the oceans, it's clearly a mixture, and so the final word is still out on that.